We're going to start chapter 6, addition and subtraction or inverse operations as our multiplication and divisions. Starting with a number x multiplied by 8 and then divided by 8, you get back the same number. So if f of x is equal to 8x and then g of x is equal to x over 8, that would be like inverse of each other. So this means that if a value of x such that x is equal to 12 is chosen, then f of 12 would be equal to 8 times 12, which is 96. Now, if I find g of 96, I get back to 12, would be 1/8 times 96 equal to 12. We're going to go over more examples of these. So the inverse function, if you recall, composition function, g composition of f of 12 is composition of g respect to f is equal to g of f of x. So this means g of f of 12 and f of g of 12 is equal to 12 and for any value of x. So this is something that you want to write down on your summary sheet right there. If composition of f respect to g and the composition of g respect to f turns out to be equal to x, then you can confirm that those two functions, f of x and g of x, are inverse of each other. So that's one way to verify whether two functions are inverse. You may want to write this on your summary sheets. This is another fact that you want to include in your summary sheets. A function f is a one-to-one function if the element a and b from the domain of x, if you pick two numbers, if a is not equal to b, implies that f of a is not equal to f of b. We're going to look at some examples to use this property, to find out whether the function is one-to-one or not. Let's take a look at these two examples. Decide whether each function is one-to-one. The first one, you can apply the same property we just learned. F of x equal to square root of 25 minus x squared. If you pick a number, any number within the range, in this case, we pick a is equal to 3 and b is equal to -3. And this is indeed our two numbers are not equal to each other. If I find f of 3 and f of -3 and come up with the fact that they are not equal to each other, then that would be one-to-one function. Remember when we said if a is not equal to b, this should imply that f of a is not equal to f of b if they're one-to-one function. So if I get f of a is equal to f of b, then one conclusion would be they're not one-to-one function, which is in this case happens. If I find f of a and f of b to be equal to 4, therefore this is not a one-to-one function. And actually we can see this using the vertical test later, which would be a lot simpler way to see whether it's a one-to-one function or not. But this would be one way of applying this property. For the second one, f of x equal to minus 4x plus 12. Now I know this is a one-to-one function because this is a straight line, and all straight lines are one-to-one function because that passed that horizontal test. We're going to talk about that in a minute. But if I find out if f of a is equal to f of b, if this is a one-to-one function, if f of a is equal to f of b, that implies that a is equal to b. This would be a property for if it's one-to-one function. So if I figure out f of a and f of b, and then I find out a is equal to b, that means that they're one-to-one function. So indeed, it is one-to-one function. And like I said, horizontal test, when you graph a function, would confirm whether it is the one-to-one function. Remember, the vertical tests were for whether it's a function or not. You draw a vertical line to see if you intercept your graph at exactly 1 point and 1 point only. If that happens, that would be a function. So now we're using a horizontal line test to see whether, if it is a function, whether it's a one-to-one function or not. So if I draw a horizontal line through a graph and intercept that graph at exactly 1 point and 1 point only, that would be a one-to-one function. Like I said, any straight line, as long as it's not the horizontal line itself, is a one-to-one function. Because if I draw a horizontal line through this line, it would intercept at exactly 1 point only. However, a circle or this kind of shape They are not one-to-one function because if I draw a horizontal line, intercept is at more than 1 point. So this is not the one-to-one function. The one on the right is a one-to-one function by using a horizontal test. So if composition of f respect to g of x and composition of g respect to f of x turns out to be equal to x, then we can also confirm that those are inverse of each other. And they have to be one-to-one in order to have an inverse. So let's f of x equal to x cubed minus 1 and g of x equal to cube root of x plus 1. Now the question is g is the inverse of f? How are we going to find that? By finding the composition of those. Those of you watching this later at home, now is a good time to pause the session to see if you can come up with the same answer that we are having now. So as shown in the figure, the horizontal line test implies that the graph indicated at the f is one-to-one. So it does have an inverse. For one thing that you want to confirm, if it's not one-to-one, then they're not going to have an inverse. So because it is one-to-one, you're going to have an inverse, so we can find that. In order to see if there are, we would find f of composition of f of respect to g and g respect to f. And then if you come out equal to x, then we would conclude that they're inverse of each other. It has to be x, not any other number. Okay, it has to be x. So in this case, if I find the composition of f respect to g and then find the composition of g respect to x, as you can see, we get equal to x. And if you remember the steps, f of x and g of x was given to me here. So f of x is x cubed minus 1. G of x is cube root of x plus 1. So to find composition of f respect to g, that's the same as f of g of x. So to find f of g of x, I substitute the value of g of x right here, which is what? Cube root of x plus 1. So now you have to find f of cube root of x plus 1. And then I have to go back to my f function to do that. So my f of x is equal to x cubed minus 1. So f of cube root of x plus 1 then would be equal to cube root of x plus 1. Then you have to cube that minus 1. So this gives me just x plus 1 minus 1. See, x, that would become x. All right, so let's take a look at the next one here. If you want to find g of f of x, similarly, you pick f of x. F of x is x cubed minus 1. So if you want to find g of that, so you go to g function. G of x is given to me as cube root of x plus 1. So g of x cubed minus 1 would be equal to substituting for each x cubed minus 1 plus 1. As you can see, you get cube root of just x cubed, and that would be equal to x. So both way, as you can see, it give you equal to x. So that confirmed that these two are inverse of each other. If composition of f respect to g of x and composition of g respect to f of x turns out to be equal to x, then we conclude that they are inverse of each other. So they are. Notation of the inverse function is f like to the power of minus 1, but that means inverse. You read it as f inverse. By the definition of the inverse function, the domain of f equal to the range of its inverse and the range of f equal to the domain of its inverse. So we have this example here. We don't have an equation, we don't have a graph, but we have some bunch of order pairs that represent these functions. If f has these order pairs, -2, 1, -1, 0, 0, 1, 1, 2, 2, 2, we want to determine whether each function is one-to-one function. So if it is one-to-one function, then we're going to find its inverse. Is the first one is one-to-one function, do you think? Remember, for being a function, you didn't want the two number would be right on top of each other, right? Under what condition number would be on top of each other? Remember when we did a vertical test, we didn't want this happens with our graph, right? We didn't want that if this is x and this is y1 and this is y2, we didn't want to have, let's say this is x equal to 1 and this is y1 is equal to 1, this is equal to 2. Like these points would represent 1 and 1, and this point represent 1 and 2. When we were checking whether we're looking at the function, we didn't want to fail the vertical test, so we didn't want this happens in our order pair. We didn't want that the first number on the x shares the different number for y. We checked the very first number on the order pair to make sure they are not equal. But for the horizontal test, we don't want this happens. We don't want that we have, let's say this is 2 and this is 4 and this is 3. Okay. We don't want this happens here. We don't want the two numbers would be right next to each other, two order pair, 2 and 3, and then here is 4 and 3. So what we don't want to have is we don't want the number repeats on the y-axis. If you see a number repeats on y-axis, it means the numbers are right next to each other. So does this happen here? Yeah, I see one repeats here, one repeats here, right? So that means these two points, if I draw these 2 points, will be right next to each other. That violates the horizontal test. And so as this one. So definitely this order pairs doesn't represent a function that is one-to-one because it fails that horizontal test. So we cannot find the inverse for that. However, the values for G, if you look carefully, there is no number repeats on the y-axis. So this is a one-to-one function. So if it is a one-to-one function, to find this inverse, just switch the position of these order pair. Its inverse would be 1 and 3, 2 and 0, 3 and 2, and 0 and 4. So as we said, the first one is not one-to-one because these numbers here, 2 and 1 repeats. So there's no inverse for that. However, for the second one, it is one-to-one function, and we just reverse these values here, and that would be the order pair for its inverse function. For a one-to-one function, f defined by the equation y is equal to f of x, define the equation of the inverse as follows. You may need to replace f of x with y first. But basically, there are 2 steps involved with this to find the inverse function. The first step is to look at your equation and replace the x and y. Everywhere you see x, you put y for it. Everywhere you see y, you put x for it. And then step number 2, just solve for y. The 2 steps involved. So you exchange the position of x and y in your equation, and then solve for y. Okay? You solve for y after you change the position of x and y. Simple as that. There are 2 steps involved to find the inverse. So let's go ahead and take a look at the example. And then we're going to use the symbol here for its inverse. Let's say we want to find the inverse of f of x equal to 2x plus 5. So I'm going to write this as y is equal to 2x plus 5. I can write it as y. And then change the position of x and y, and then solve for y. So we know we have a inverse function because this is a one-to-one function. Any straight line, as long as it's not a horizontal line, it is a one-to-one function. So you see y is equal to 2x plus 5. You exchange the position. You put x is equal to 2y plus 5, and then you just solve for y. To solve for y, you subtract 5 from both sides of the equation, divide each term by 2, and there it is. This is the inverse of this function. So if y is equal to 2x plus 5, its inverse using this method is x minus 5 over 2. Or if I call this f of x, so this would be inverse of x. That's what the symbol we're going to use. Okay, so 2 steps involved. You exchange the position of x and y and then solve for y. Okay, let's find the inverse function for this one. This is x squared plus 2. F of x equal to x squared plus 2. Isn't this a vertical parabola? Remember, this was a equation for y is equal to x squared, right? And this would be the one that is shifted. But regardless if shifting or not, if it's a vertical parabola, it's gonna fail the horizontal test. So when we're looking at the horizontal parabola, this is not a one-to-one function, therefore it doesn't have any inverse. Once you find it's not a one-to-one function, you can stop, so there's no inverse there. How about this one? f of x equal to x minus 2 cubed. If you look at the graph of that, the graph passes the horizontal test, so it is 1 to 1, so I can find the inverse of that. So I can write as y is equal to x minus 2 cubed, exchange the position of x and y, and then solve for y. You substitute for each yx, for each xy, and then you simply solve for y. To solve for y, I need to eliminate this 3 here, power of 3, by taking a cube root of both sides, and then just isolate y. You add 2 to both sides of the equation. So y would be equal to 2 plus cube root of x, and that is your inverse. Now, one important fact that you want to remember about inverse function, if two functions are inverse of each other, remember the order pair switches. AB would become BA. So that means the graph of your function and the graph of your inverse have a symmetry with respect to x is equal to y line. So this is the fact that you want to remember, that if a function is 1 to 1, the graph of its inverse is a reflection of the graph of the line y is equal to x. So let's take a look at this example. If I have this as being my graph, I should be able to graph my inverse function if I just draw y is equal to x line and find the reflection of that. So if you look at y is equal to x line right here and measure the points from each side, then I can find the graph of my inverse function. If f of x equal to square root of x plus 5, you want to find the inverse. This is a 1-to-1 function. The domain of f is restricted to -5 to infinity, and the range is from 0 to infinity. So it is a 1-to-1 function, so we can go through the steps. So y is equal to square root of x plus 5. You substitute for each yx, for each xy, and then solve for y. This would be my inverse function. And as you can see, the range of f is in the domain of inverse, and we confirm that fact that we discussed earlier. Here we have f of x equal to 2x over x minus 1. It says it's 1-to-1 function already, so we want to find its inverse. So you write as y is equal to 2x over x minus 1. We exchange the position of x and y, and then solve for y, and that gives you the inverse function. Go through the algebra to find the inverse function. So the inverse of 2x over x minus 1 would be x over x minus 2. If you actually graph these two lines, you see there a reflection of x equal to y. If f is a 1-to-1 function, then its inverse exists. That's something we covered. The domain of f is a range of its inverse, and the range of f is domain of its inverse. That's another fact we looked at. If the point AB is on the graph of f, then the point BA lies on the graph of its inverse function. So then the graph of f and graph of its inverse function are reflection of each other across the line y is equal to x. So these are the three facts that you want to remember. This is the example. Use the 1-to-1 function f of x equal to 3x plus 1, and the numerical value shows to encode and decode the message. Call at night. Okay, so in this case here, A corresponds to 1, B corresponds to 2, C corresponds to 3, and all the way Z corresponds to 26. Call at night would be encoded as, you have to use this formula here, as these numbers, 10, 4, 37, and so on. Why? For instance, C, letter C, correspond to number 3. So I have to put that number into this equation, f of 3. F of 3 would be equal to 3 times 3 plus 1, which is equal to 10. So that would be the number correspond to letter C. So nobody would know that until somebody would give me the equation. You can use any equation you want for encoding and decoding. So if you know the encoding and decoding that you have correspond to this equation, f of x equal to 3x plus 1, then you can go through this calculation and figure out that the letter C corresponds to this number 10. So using the method of earlier example, we find that this could also written as inverse x minus 1 over 3. If you remember, we already figured out this inverse in the previous example. This is really is 1/3. This is the same as 1/3 x minus 1/3. So we can, using this inverse function, we can go backward. What is the inverse function when x equal to 10? So I have to go back and do that. Like I would get 3 again. So remember, 3 was correspond to 10, so 10 must be correspond to 3, decoding that. And we can use the graphing calculator to convert this result here. If you put the equation there, and you can see all the codes can be encoded and decoded here accordingly by just putting the x, and you can get the value of y, or vice versa.